Hello everyone, my name is João Victor Bolson Marques. I'm a master's student at Universidade Federal de Santa Maria in Brazil, and today I'm here to present to you our study Algorithm for Selecting Words to Compose Phonological Assessments. So first, to contextualize the presentation, I'm gonna give you a small introduction about our subject. After that, I'm gonna talk about our proposal, the study itself. Then, I'm gonna present to you the results and the validation of our study, to finish the presentation with a conclusion. So, in the domain of speech therapy, in order to evaluate phonological disorders, it is necessary to apply a phonological assessment. A phonological assessment is a tool that allows the speech therapist to identify the correct pronunciation of each phoneme by exposing the subject to images that represents a target word. A target word must be spoken naturally. So here is an example of the digital assessment. So when the subject sees this image, he must speak naturally the word cavalo, which means horse in English. This is commonly used to apply phonological assessments on children. So the set of target words that compose a phonological assessment must contain a representative sample of the complete phonological system, which means all the phonemes that a grown person can speak. Some of those sets have been proposed along of the years, such as the one proposed by 5, which contains 125 words. So the set of target words must contain at least 2 words that analyze the same phoneme in the same position. This redundancy allows the speech therapist to reduce false positive and negative cases of phonological disorders. So here is all the possible phoneme positions. So, for example, the medial onset is when the phoneme is at the beginning of the syllable and in the middle of the word. So this phoneme here, the phoneme V in the word cavalo, is at the beginning of the syllable, here in the middle of the word. So now let's talk about our proposal. Our work based on a set of 84 words proposed by 1. This set has at least 2 occurrences of the same phoneme in the same position in different words. The data structure shown in the figure was developed in tree, and it was used in our work to build a list of phonemes present in each word. So here we have the word cavalo, decomposed in 3 phonemes, K, V, and L. So the first step was to do a phoneme mapping and a graph. To do so, each phoneme occurrence in each position was counted, in order to build a graph with the following information: the words in which the pair phoneme position appears, and the connection between those phonemes. This is important to know what notes will be affected in case of removing words. So for example, if we remove the word pedra, which means rock, from this note here, we won't affect only this note. We will affect this note here and this note here, because pedra is present in all of them. So now let's talk about our method, which consists in 4 steps. The first one is to choose a non-visited node. In this example, we choose the node P, evaluated at initial onset. This phoneme is evaluated at this position in 4 words. I'm gonna take a glass of water. I'm a little cold today, sorry. So, passarinho, which means little bird in English, is present in another 2 notes, S in medial onset and R in medial onset as well. So the node S at medial onset has 6 words and R has 10. We do the same thing for the other words. After that, we sort this list according with the second column in order to have the list of the most important words. I'm sorry. So the most important words will be the ones who have connections with nodes that have a small number of words. So for example, pedra is the most important word of this node, because pedra has connection with another node that have only 2 words. We shown this before. Here, pedra is at this node, and this node here has only 2 words. So if we remove pedra from this node, this phoneme will be evaluated at this position only one time, and this is not according with our criteria. So the next step is to decide if you can remove the others words. Now that we defined that each node must contain at least 2 words. So we removed passarinho and pastel because we won't affect negatively others nodes. The next step is to reorganize the nodes according with the weights and update the graph. We do the same thing for the others non-visited nodes. So here is the first round result. I'm sorry. This node here is have only 2 words, and this is according with our criteria. This one too, and the others connections was removed because it doesn't exist anymore. I'm a cold and I'm a little nervous too. After all nodes have been computed, the initial set of 84 words was reduced to 55, with each phoneme being analyzed at least 2 times in the same position. In order to predict how the final set will behave in a real scenario, we compared our set with the initial one using the PCCR equation. So the PCCR equation indicates the level of speech disorder, based on the number of correct and incorrect consonants spoken on the evaluations. So for example, if the subject spoke less than 50% of all the phonemes in the evaluation, he must be bad. So the indication of disorder will be high. We use data collected from more than 1,500 evaluations, which had at least 50% of the initial set spoken by the subjects. These evaluations were applied in more than 1,300 children between 2013 and 2017, and stored in a database used by our group. With this data, we were able to compute the PCCR value for each evaluation. So first, the PCCR were calculated for each evaluation, considering all the 84 words from the initial set. Then we did the same thing again, but now considering only the 55 words. The main idea here was to identify if the indication of disorder would still be the same when using less words. So we found that 96% of the evaluations didn't have changes in the indication of speech disorder when only 55 words were used. So for example, a child who spoke 84 words having a low indication of disorder would still have the same indication if she had spoken less words. The remaining 4% had changes mostly from low to moderate low, which means small jumps between different degrees. So to finish, our work aimed to accomplish a computational analysis of 84 words using an instrument of phonological assessment. It was found that some phonemes were overrepresented in the set. The words that were that were causing this superrepresentation were identified and removed, following logical criteria. So 55 words were left as the final result, representing a reduction of 35% of the initial set. The initial set was still able to analyze each phoneme in each position at least 2 times. The set was tested using real data collected from more than 1,500 evaluations, by comparing the indication of disorder using the full set of words and the reduced one. 96% of the assessment had the same indication of disorders when using less words. So thanks for the attention, and I'm sorry again for my nervousness. and bye.